This video looks at a couple of past paper questions on work done. Okay, pause the video and have a read through this question and then give yourself 3 or 4 minutes to answer it and press play when you're ready. Okay, it starts by asking us to write down the equation which links distance, force and work done, and of course that is work done equals force times distance. And then the second bit here is a calculation. So we're given some information here. We've got the work done in joules, we've got the height or distance, and we're asked to calculate the force. So we know which equation we're going to use. Let's write down the equation first, and then we're going to put the numbers in. So in this case, we actually know the work done. So we've got 3,430,000 is equal to the force, which we don't know, multiplied by the distance, which is 14 meters. So we need to find force. So as force is currently multiplied by 14 on the right hand side, we reverse maths and divide by 14 to get the answer. So we've got 3,430 divided by 14, and the answer comes out at 245,000, and the units newtons are already given to us there. Okay, pause the video again and have a read through parts C and D. Give yourself around 5 minutes and then press play when you're ready to go on. Okay, part C asks us to write down an equation that links power, time and work done, and this is slightly sneaky because actually we have to remember here that work done is the same as energy, so we're really looking for something that relates power, time and energy. So we have an equation that says that energy equals power times time. If we then substitute in work done, we end up with work done equals power times time. Next part of the question then, we are told that the power of the crane is 68,600 watts. We know the amount of work done by the crane and we're asked to calculate time. So we are using the equation above. Don't forget here it says give the unit. So many people miss that extra mark. So we're going to put out the equation here. We've got work done equals power times time. So we've got our 3,430,000 equals 68600 multiplied by time, and we don't know what time is. That's one we've got to find. So to rearrange and get time on its own, it's currently multiplied by the 68,600, so I'm going to have to reverse math and divide. So I've got 3,430,000 divided by 68600 to give me the time, and that comes up at 50, and of course we've got the unit of seconds. Okay, pause the video, have a read through question 2 part A, and then when you're ready, press play to continue. Okay, so we're asked to write down the equation that links distance, force and work done, rather the same as the last question. So again, we have work done equals force times distance. Okay, second part of the question then, we've got a calculation coming up. So we're going through a height of 200 meters. We've got to do the work done. So we're going to be using the equation above. And we need a force. So we go to the top of the question where we find out that Greg has a weight of 700 newtons and Jill has a weight of 500 newtons. Now they're both going to the top of the ski lift, so we're going to have to add those two weights together to get the total weight. Remember, weight is a type of force, so in this case work done is equal to weight times distance, or weight times height. So I'm going to do 700 plus 500 to give me the total weight, which is 1200 newtons. We're then going to use the equation work done equals force times distance and put the numbers in to give us 1200 multiplied by the 200 meters, which gives me 240,000. Now don't forget we have to put in the unit, otherwise we miss one of the marks. And because we've got work done, which is a type of energy, the unit is joules. Okay, pause the video again to have a read through the next part of this question. Give yourself 4 or 5 minutes to have a go at the answer and then come back when you're ready. Okay, so we're starting up with the calculation again. We're told here that the chair is going to take 5 minutes to move from the bottom to the top. And the first thing I think when I see that is that minutes is not a standard unit and I want to convert it. So I'm going to do that over here. Remember, there's 60 seconds to a minute, so 5 multiplied by 60 will give me 300 seconds. Okay, then going back to the calculation, we're asked to calculate power. We've got time up here, and in the last section of the question we'd already worked out the energy, which was the 240,000 joules. So power then equals energy divided by time. So there's the 240,000 joules we've just calculated divided by the 300 seconds, and that will give me 800 watts, and the unit's already here. Okay, part C. Why would the power output of the electric motor need to be larger than the answer to part B? So this is a reminder then of what happens in energy transfers. So I've got an electric motor which is going to be providing electrical energy, which will then be transferred into kinetic energy, moving the ski lift, and gravitational energy as it gets towards the top. Now we know that efficiency cannot be more than 100%, which means that what goes in has to come out. If I put in, for example, 100 joules of electrical energy, I can't get any more than 100 joules out. Now, if we bear in mind some of that energy is going to be wasted due to frictional effects, for example, then the 100 joules in is not going to convert into 100 joules of gravitational energy out. So the reason is because nothing can be more than 100% efficient. Or perhaps an easier way of writing the same answer is just simply to say because energy will be wasted. Even better, I would give an example, e.g. frictional effects. Okay, then the last part, I'll just change colour to make that clearer here. When the ski lift is working, we have electrical energy supplied to the motor, which is transferred as gravitational potential energy. A nice fill in the gaps to finish. Okay, pause the video and have a read through question 3. I'd give yourself 4 or 5 minutes to try the answer and then come back when you're ready. Okay, we're starting off with another calculation here. So the driving force is 250 meters and the cyclist travels 5 meters, and we've got to find work done. And again, as usual, it says we need to show our working. So we know work done equals force times distance. So putting the numbers in, I've got 250 newtons times 5 to give me 1,250 joules is already given to us. Part B then, what happens to the energy transferred by this force? Well, just notice there's 2 marks, so we do need to say 2 separate things. I would always put a couple of bullet points here to remind myself to do that. So the first thing then is that the energy is going to be transferred to make the cyclist go forwards, so it's going to be transferred into kinetic energy. Now we're also going to get some energy wasted as heating effects from friction and air resistance. So we need to mention that as well. And here I'm going to say to the surroundings. You could also say to the environment or the atmosphere. And I'm putting friction here, but you could also say air resistance.